The Earth, the birthplace of humanity, as we know it, with its seas, oceans, deep forests, and majestic mountains. It is the only place we know of where life exists, both due to its distance from the sun and the presence of liquid water. Intelligent humans have been nurturing and sustaining this planet, where they began to walk on from the stage of our existence. We can drink its vital waters for our bodies, use coal and gases for warmth, and rely on trees for breathing. It seems as if everything is serving us. But our beautiful and vibrant living blue planet is filled with terrifying and incredible extinctions in its geological history. It has experienced 5 major mass extinctions that have brought life on the brink of extinction. Based on the extensive scientific evidence obtained by geologists and radiometric age measurements on zircon crystals, our planet's age has been determined to be 4.5 billion years. During this time, many things have happened. Although life has come to the brink of extinction 5 times, it has somehow managed to hold on, restart each time, and rise from its ashes. From its formation to the present day, Earth has passed through geologically 5 eras, 3 eons, and 12 periods. In 5 of these 12 periods, significant catastrophes occurred. Now let's take a journey through time together to witness these 5 major extinctions and how life managed to flourish again afterward. Ordovician period. The Ordovician period is considered the second subdivision of the Paleozoic era, believed to have started 495 million years ago and ended 471 million years ago. During the Ordovician period, continents that had mostly gathered in the southern hemisphere during the Cambrian began moving in 2 different directions. Gondwanaland, the largest continent, moved toward the South Pole, while the other 3 continents moved northward towards the equatorial region, approaching each other. Throughout the era, fluctuations in sea levels exposed these continents to the influence of the seas repeatedly. The climate during the entire period was mild and rainy, with extensive shallow seas in various regions. These conditions allowed species to adapt to different environmental circumstances in diverse ways, resulting in the emergence of numerous subspecies that found opportunities for development. The period in which this type of diversification, defined as adaptive radiation, was most prominently observed is the Ordovician period. The significant diversification in marine invertebrates and single-celled or planktonic organisms is known as the Ordovician adaptive radiation. During this period, the ancestors of new groups emerged, including mussels, bryozoans, from sea anemones to sea cucumbers, sea urchins, and sea snakes. The rapid spread of small species of single-celled and planktonic organisms in the oceans led to the discovery of a feeding method that involved filtering seawater. The significant influence of these species was also evident in the formation of vast reef systems in shallow seas. 3-lobed organisms, which had their heyday in the late Cambrian, were heavily affected by the Cambrian mass extinction. However, during the Ordovician adaptive radiation, they diversified by occupying the ecological niches left vacant by the extinct Cambrian organisms. In the Ordovician, the 3-lobed organisms, which were widespread, developed significantly different forms from their ancestors in the Cambrian. While many developed structures such as spines and joints, some fused certain body parts. As a result of adapting to different environments, some had giant eyes, while others completely lost their eyes. Some developed snout-like noses, suitable for a mud-digging lifestyle. Members of eukaryotic life first ventured onto land in the Ordovician. The initial evidence of animals venturing onto land is the fossilized footprints they left behind while wandering in what was once a beach area. Towards the end of the Ordovician, Gondwana's movement towards the South Pole blocked warm ocean currents moving from the equator towards the South Pole. Without these surface currents to make the South Pole more temperate, extensive ice sheets formed, hundreds of meters thick in places. While this glaciation hardened the climate across the planet, it also resulted in a significant amount of water being bound up in ice, causing a drop in sea levels. The retreat of shallow seas led to the extinction of numerous species inhabiting these waters. with some likely adapting to terrestrial life. Many species, especially those in temperate seas, were lost, primarily in reef environments. The extinction initially affected tropical species like plankton, echinoderms, trilobites, and armored fish. Later, it targeted corals and brachiopods. Green algae, which had adapted to temperate seas, also suffered from this extinction, with nearly half of their species being lost by its end. As a result, the chemical balance of the Earth was disrupted during the Ordovician, plunging the world into a terrifying ice age. Consequently, nearly the entire surface of the Earth was covered in ice, and approximately 70% of life forms perished. There are also theories suggesting factors such as volcanic activity, causing a decrease in carbon dioxide or damage to the ozone layer due to gamma ray bursts. Devonian period. The Devonian period, which is the fourth subdivision of the Paleozoic era, is a geological time period during which the Devonian rock system is believed to have formed. It is assumed to have started around 417 million years ago and ended approximately 354 million years ago. At the beginning of the Devonian period, there were two giant continents on Earth, Gondwanaland and Laurussia. Gondwanaland was moving towards the South Pole, while a significant part of Laurussia was starting to compress from the south. By the end of the period, these two continents would merge to form the single supercontinent known as Pangaea. New mountain formations emerged along the long boundary where the two continents collided, and intense volcanic events took place. Many mineral deposits found near the Earth's surface today originated during this period. The pressure exerted by magma on the ocean floor between the two continents led to uplifts. As a result, sea levels rose worldwide during this time, covering about 85% of the planet. Present-day North and South America, Siberia, and a large part of Austria were covered by shallow seas. The first tropical rainforests emerged in the northern part of today's Karoo Basin and in the southern region of China. Meanwhile, glaciers were present in the Amazon region at the South Pole. During this period, the climate was warm and even hot, while the interiors of continents were arid. The Devonian's warm and shallow seas hosted a diverse range of invertebrate groups. Reefs, formed by the coexistence of corals, sponges, and algae, were widespread during this time. Brachiopods, one of the most common groups of the Silurian, continued their success in Devonian seas, reaching their peak in terms of diversity and prevalence. Mollusk groups like snails and mussels maintained their status from the Silurian period. But a new group, the ammonoids, with coiled chambered shells, emerged from nautiloids. The shells left behind by ammonoids, which became quite common after this period, constitute today's limestone deposits. The once dominant trilobites from the Cambrian and Ordovician periods had dwindled significantly. Only a few groups remained widespread, and some giant forms had evolved. It is believed that the increase in the number of free-swimming predatory animals like fish and cephalopods played a role in the decline of trilobites. Most of the trilobite groups disappeared by the end of the Devonian period. While various fish groups that emerged in the Silurian continued to thrive, numerous new fish groups appeared and rapidly diversified during the Devonian. Due to the diversity and prevalence of fish groups during this time, the period is referred to as the Age of Fishes. Armored fishes, known as jawless fish that first appeared in the Ordovician, were present throughout the Devonian, but they largely disappeared with the end of the era. Following the emergence of the first jawed fishes at the end of the Silurian, cartilaginous fishes, sharks, and rays also made their first appearance during the Devonian. Plants underwent a significant evolutionary leap during the Devonian, with early Devonian plants being only 15 to 20 centimeters tall. These were primarily moisture-dependent, leafless, herbaceous, and creeping plants. Towards the end of the period, mature trees, reaching heights of up to 30 meters, formed forests that covered the Devonian continents, marking the emergence of the first seed-bearing plants. While this evolutionary development in plants may not closely resemble the Cambrian explosion, it is regarded as the Devonian explosion, signifying a revolutionary leap in plant life. The Devonian period, where plants experienced a remarkable leap in diversity, also witnessed a similar diversity and development in arthropods, emerging roughly simultaneously. Members of the early Devonian fauna were predominantly arthropods, and towards the end of the Devonian, a mass extinction event occurred. The absence of ecosystems at the beginning of this event severely impacted marine life, resulting in substantial consequences. Reefs completely disappeared, and coral populations significantly declined. Trilobites, eurypterids, and primitive fish groups either went extinct or suffered significant losses. Planktonic graptolites completely vanished. Tropical species were more affected compared to temperate ones, leading to the extinction of many warm water species. Permian period. The Permian period, which marks the sixth subdivision of the Paleozoic era and is associated with the formation of Permian rock systems, is estimated to have begun around 292 million years ago and concluded approximately 252 million years ago. Since there was no mass extinction event at the end of the Carboniferous period, marine life continued much like terrestrial life into the Permian. Prolonged arid conditions on land adversely affected rainforests. Towards the end of the period, rainforests nearly disappeared, and terrestrial vegetation primarily consisted of gymnosperms, including coniferous trees. The Permian saw a widespread diversification and development of vertebrate fauna, marking a period of proliferation for reptiles. The fossil records of Permian reptiles are extensive. The mass extinction event that occurred at the end of the Permian, where approximately 95% of all species perished, stands as the largest extinction event in the Phanerozoic eon. Land-dwelling species, including vertebrates, insects, and plants, saw the disappearance of nearly 70% of their populations. Nevertheless, compared to animals, significant plant groups didn't entirely go extinct. The result of this vegetative extinction, what was lost, is still a subject of debate today. While many scientists accept the theory that an astronomical object struck the Earth, the fact that 90% of marine life went extinct and 2/3 of terrestrial reptiles survived provides grounds for scientists to argue for other reasons. Global cooling, volcanic activity on the ocean floor, especially in Siberia, are among the reasons cited. Triassic, Jurassic period. The Triassic period is a geological time period that is considered the first subdivision of the Mesozoic era, believed to have started 251 million years ago and ended 205 million years ago. Towards the end of this era, the supercontinent Pangaea, which formed towards the end of the Paleozoic era, began to break apart. North America and Northern Europe separated from Pangaea, and the once prevalent arid and continental climate of the time transitioned to a desert climate in the inland regions. During the Triassic, marine life took on a more modern appearance, with a significant difference being the dominance of giant sea sponges as top predator species. Sea turtles and crocodiles also emerged during this period. Modern-day corals first appeared in the Tethys Sea, which transformed into a tropical sea abundant with coral reefs. In the arid regions of Pangaea, seed plants, particularly coniferous trees, became more widespread. The first mammals also emerged towards the end of the Triassic period. These were small-bodied creatures. The first dinosaur species also belonged to this period. However, towards the end of the Triassic, a mass extinction event occurred for reasons that remain unknown today. 35% of animal species and 50% of marine life were affected by this extinction event, and the first dinosaurs completely vanished. The Jurassic period followed the Triassic in the Mesozoic era. During the Jurassic, the single continent of Pangaea moved northward, became compressed in northern latitudes, and began to break apart. These separations created large and extensive rifts among the landmasses. During these rifts, numerous volcanic activities occurred, and in the subsequent Cretaceous period, present-day Northern Europe and North America would be separated by a narrow seaway. The Jurassic climate is milder than the Triassic. The differences between climates were vague. Rainfall increased, temperatures dropped, and the rising humidity led to strengthened plant life. Throughout most of the period, there were no ice caps at the poles, resulting in higher sea levels. Rising seas inundated parts of the continents. A minor extinction event at the end of the Triassic allowed dinosaurs to proliferate during the Jurassic. Dinosaurs diversified and thrived, reaching colossal sizes. Enormous sauropod dinosaurs like Diplodocus and Apatosaurus diversified in the early Jurassic, and the number of carnivorous theropods like Allosaurus and Compsognathus also increased. As bird-like dinosaurs became more prevalent, primitive bird-like creatures like Archaeopteryx emerged towards the end of the period. While dinosaurs ruled the land, pterosaurs, the largest flying vertebrates known, took to the skies. Ichthyosaurs, plesiosaurs, and giant sea crocodiles claimed the top spots in the marine reptile hierarchy. Despite reptiles having a significant advantage during the Jurassic, primitive mammals continued to evolve and diversify during this period. It is believed that the first flowering plants also evolved towards the end of the Jurassic period. A minor mass extinction event occurred at the end of the Jurassic. Terrestrial ecosystems, especially dinosaurs, were not significantly affected by this extinction event. However, marine reptiles, as well as many shallow water species, including 80% of mussel and oyster species, went extinct. The cause of this extinction event is unknown, but there are suspicions that a series of events triggered by the release of vast methane deposits into the seafloor could have contributed to the extinction. After the Jurassic, the Cretaceous period began. The last of the three subdivisions of the Mesozoic era is believed to have started 142 million years ago and ended 65 million years ago. It is also known as the Cretaceous period. The abundance of chalk and rocks dating to this period gave rise to the name Cretaceous. Chalk is a product of dead plankton settling on the seafloor due to water pressure. The process of continental fragmentation and shifting continued during this period. At the end of the period, Antarctica and Australia split apart. India and Madagascar continued to move northeastward. Italy and Greece approached the European continent within the Tethys Ocean as a single mass. Eurasia was still in its complete form. North America, on the other hand, collided with Western Europe towards the end of this period. By the end of the period, South America also separated from Africa. During the Cretaceous period, as in the Jurassic, a temperate and rainy climate prevailed on the planet. Seasonal differences were not pronounced, partly due to the land masses being at nearly the same level and lacking significant elevations. There were no glaciers at the poles, and sea levels were high. The temperate climate, lack of seasonal variations, and ample rainfall contributed to the abundance of minerals carried to the seas. Shallow seas, combined with the limited spread of planktonic life in these conditions, provided a suitable environment for marine creatures that feed on plankton. In this environment, reefs rapidly spread in shallow and temperate seas. The proliferation of reefs created a vast environment for the development of numerous species. In addition to the known species like mussels, oysters, and sea urchins, advanced crustaceans such as octopuses, crabs, and lobsters also became widespread. In deeper waters, there were cartilaginous apex predators, while in shallow waters, reptilian species adapted to the aquatic environment became prevalent. Both groups exhibited a tendency to grow increasingly larger over time. The dominant plant life from the previous Jurassic period continued to prevail until the end of the Cretaceous. Flowering plants, which began to emerge at the beginning of the period and became the dominant plant type by the end, represented a distinct phase of evolution that defined this era. Oak species, maple, magnolia, walnut, birch, and beech trees are surviving forms of woody flowering plants. Between 90% and 95% of today's flora consists of flowering plants that emerged in open niches during this period and later became widespread. The advantage of flowering plants lay in their ability to utilize various species, such as insects, for reproduction and propagation. Alongside the dinosaurs of the Jurassic period, new species emerged during this time. The Cretaceous period marked the golden age of dinosaurs. However, when a celestial body struck the planet at the end of the Cretaceous period, approximately 70–80% of all species on Earth perished. The most heavily impacted were generally reptiles, particularly dinosaurs. All non-avian dinosaur species went extinct. Dinosaurs had ruled this planet for 175 million years. But how did they manage to survive for such an extended period? There are 5 significant reasons for this. 1. They largely overcame the pressure exerted by archosaurs, which diminished with the disappearance of the Triassic-Jurassic. 2. They demonstrated a remarkable capacity to adapt to ecological systems. 3. They thrived on highly diverse diets and filled ecological niches. 4. They made substantial evolutionary advancements in reproduction, defense, body temperature regulation, and nutrition. 5. Being one of the most dominant species of their time, they had virtually no natural predators. Nothing on Earth could challenge their dominion. But what brought about their demise was an extraterrestrial threat. An asteroid larger than Everest Mountain, which would forever alter Earth's fate, collided with the planet's surface. The impact unleashed energy equivalent to millions of nuclear weapons. Life in the vicinity of the impact was instantly obliterated due to the shockwave. The asteroid struck with such speed and force that shattered fragments rained down nearly thousands of kilometers away from the impact zone. The collision also triggered earthquakes and tsunamis. As the Earth's surface heated up to 275 degrees, vegetation and the creatures dependent on it disappeared. For months, the smoke and ash resulting from the impact blocked sunlight from reaching the planet, and the asteroid altered the planet's geochemistry. Oceans became acidic, climate fluctuations began, and tectonic movements were set in motion. These seemingly invincible dinosaurs were helpless against such an onslaught. Their 175 million year reign came to an end. Thank you for watching the video. If you enjoyed this content, please don't forget to like, subscribe to my channel, and by sharing this information with the people around you, you'll be providing me with tremendous support. Your support and every comment you write are very important to me and contribute to the continuation of such content. Yes, my friends, I'm just lonely human. See you in the next video. Take care.